Thank you all. I usually start these things with a really quick, like, show of hands poll. When we talk about dependency injection, how many people are familiar with using dependency injection, know it and love it? Perfect. There's like 3 people that the first 3 slides are for, and then we'll, skip right on past that. And how many people have used Dagger 1? And Dagger 2? Oh, you guys are my favorite. All right, so let's get started. We're going to talk about Dagger 2 and really what we've introduced since the last time I got up on a stage and talked publicly. That was been quite a while ago. We've had several incremental releases, and then our plans for the future. Looks like we're going with the keyboard. Oh. Looks like we're not clicking at all. There we go. He told me it would be working. It was a lie. All right. So a quick reintroduction to dependency injection. Like, let's just cover the bases, make sure the fundamental thing we are talking about is off on the left. We have an example. If you want a coffee maker and you want and that coffee maker requires an electric heater and a thermosiphon and all of this nonsense, one option is when you create the coffee maker in your constructor, make all the things you need. That's one viable option for making functional software. Dependency injection is simply the act of saying, rather than creating all of the things I need myself, I am going to pass them in. So in this example, the main method first creates the heater, then creates the thermosiphon, and passes them to the coffee maker. That is great. That is a pretty simple difference. And we're going to go through why that can be beneficial, particularly in your mobile or Android apps. DI with Dagger 2, how we do this when we're using Dagger 2, which presumably most of the audience knows already. We have the inject constructor. The inject constructor says, framework, please provide me a heater. Go ahead and invoke this constructor the way that you normally would, but make the framework responsible for fulfilling all those dependency requests. We also have a little bit of static configuration in the form of provides methods, just like your inject constructor, only an external method in a module that you provide as configuration. So if you want to say the heater that I'm using is an electric heater, you can write a method to express just that. We also have on that annotation singleton says, how many of these do I want per my application? And singleton, just like the design pattern, means just one. So dependency injection will manage the number of instances for you. And the magic of Dagger 2 over Dagger 1, or really any other solution, is we do this all in a fully type-safe way. Most dependency injection solutions prior to Dagger 2 would say, pass me in a class literal, and we will give you back an instance, and you may or may not have to do some casting, depending on how far along they were. Dagger 2 instead says, make an interface with type-safe methods that look just like the methods you might have otherwise written, and then we're going to implement those methods for you based on your configuration modules. So when we ask for a coffee maker, we just invoke that maker method, and it gives us back a coffee maker in a completely and totally type-safe way. Okay, but why are we doing this? Why are we bothering with dependency injection? What's the point? For all of you that have adopted dependency injection, I'm sure you've heard the whole laundry list of reasons. You can talk about coupling, you can talk about testability, you can talk about organization, you can talk about any number of things, blah, 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 blah. Today, we are going to talk about how it translates specifically to your mobile applications in the form of consistent and efficient instance management. We all know that mobile devices are constrained, and by and large, as a programming language, Java plays pretty fast and loose with objects. It's really object creation, allocation happy, but that doesn't work so well when you don't have a lot of memory and you don't have a lot of CPU to burn on garbage collection. So proper object management is tedious. It's easy to get wrong. It's easy to forget about. It's really hard to do uniformly. So we introduced dependency injection, and specifically Dagger 2, as a way to do that, and a way to manage your objects in such a consistent and efficient way that you don't have to worry about that nearly so much anymore. You can express what you want to do functionally, like at singleton or something like that, and Dagger will just take care of doing it the correct way, which sounds great. So how do we do that? Well, in Dagger 2.0.1 through 2.4, that is, from the last time I talked publicly about Dagger 2 until today, we have introduced a lot of features that help you do that. This first one is possibly my favorite, only because it's so silly, which is static provides methods. Static provides methods seems as simple as it truly is. This is a provides method you might have written before. Provides heater, provide the electric heater. We have now enabled you to do that. Okay, what's the point? Why is this a big deal? Yeah, there you go. Clap for that. If you look at the Android developer documentation, and I still kind of squint this claim, I'm not entirely sure that I believe it, but I'm going to take them on their word for at this moment. They claim that invocations of static methods are 15 to 20% faster than the equivalent non-static methods. So for every provides method that you can now make static, invoking that method just became 15 to 20% faster. Okay, why wouldn't we do that? Of course we'd want to do that. But more importantly, the second and third order effects of static provides methods are huge. If you have an instance method, you need an instance. You must invoke that method on an instance, by definition. If you have static provides methods, you no longer need an instance of the module. If you don't need an instance of the module, you don't need to allocate an instance of the module. So when you create your singleton components, and when you create your activity components, and when you create your possibly fragment components or whatever it is, now all of a sudden you're creating many fewer objects. You're assigning many fewer references. Consistently applying static provides methods makes your application more efficient across the board. Great. That was the easiest thing, and I'm glad we did it. Subcomponents was another big change that we introduced that has a lot of great effects for your Android application. Subcomponents are a pretty simple concept in that you often have this case where, all right, I've got a bunch of things happening at the application level. Now I have a bunch of things happening at the activity level, or in this case, like a server-side case, it's a bunch of stuff happening at the server level, and then for every server you get a session. Every session has some number of requests. Well, all the bindings, for instance, authentication bindings that you might need, you want those available in the session, and everything from the session you want available in the request. So by defining subcomponents, you propagate all of the bindings down into smaller scopes. So in this example, the server component exists, and you can create the server, but then you can also create a session component from the server component. So invoking that method creates a new session component with the session scope, and then similarly, creating a new request component from the session creates a new component for the request. On Android, the analog would be application component creates activity components, and activity components can create fragment and view components however it pleases. This is just a good way to be able to expose all of these bindings from the top down without having to propagate them through manually. Just reduces a lot of boilerplate. You can only really describe that so much in one slide, so if you guys are interested in how to apply that, the docs are pretty extensive on that. Map multi-bindings is another one that's actually kind of a feature that's easy to miss, and sort of like static provides methods, it's powerful in a way that's not necessarily expected. So the motivating example is something like this. This is a screenshot of Hangouts ripped right from the Play Store. And there are two things going on here. There's an adorable picture of a puppy and a little smiley emoticon. You have this big container in the middle, and in that container you might have photos or locations or text or whatever have you, and you don't know which of those, you need to render that data that comes in as messages somehow, and you don't know specifically what type it's going to be until runtime, until you have some data. And the question is, how do you tackle that efficiently with Dagger 2? Well, if you imagine that, for each of these messages, there's an enum. Yeah, I know. We'll debate about that later. But there's an enum for message type, text, photo, and location. You can introduce a new annotation that is map key. And map key just says, here's what type of message it is. And now, just like set bindings, you can aggregate these all together. In this case, we're going to aggregate renderers. Renderers being how you turn that message into something that shows up for the user. And you key it, for example, the first one is for message type text, and then you provide a renderer. The second one, for message type photo, you provide a renderer. And for message type location, you provide a renderer. And then you can actually, rather than like you would with set multi-bindings, inject a set, it's just a flat set, you can inject a map of that enum message type to provider of renderers. You can also just inject the renderers, but for this example, we're going with the provider. You can just inject that map. So as you're iterating through the messages that come in as your data, you can say, okay, get me the renderer for my specific message type. Now use that renderer to render the message. The magic of this, the reason that this is so powerful, is that entire map was composed statically. We know every entry in that map at compile time. There's no runtime, there's no reflection. You get something that looks like dynamic reflective behavior, but without the cost of reflection, which is obviously great for Android. Again, that's in the user guide and explained in much, much greater detail than I ever could. So if this sounds like something your app might do, I would recommend checking that out. Producers is another feature that is way more powerful than I can even begin. Huge portions of our search stack, both on the server and on mobile, are implemented using producers. And if you think about it this way, provides means synchronous operation, it means invoke a method. Produces means asynchronous method. And we don't use RxJava or anything like that for this implementation. What we use is just normal listenable features straight from Guava. And this should look extraordinarily similar. It looks exactly like modules and provides methods and all of those things that you would typically see, but we've replaced provides with produces. And what that means is when the inputs to a given method are finished, go ahead and invoke the next one. So in this example, we say, okay, we're going to invoke this stub to look up user data and return a listenable future. That's presumably some RPC somewhere. That's an extraordinarily long-running operation. But then right below it, we want to render the HTML as the result of that user data. We just say, okay, once we get the user data, once that's available, once the listenable future has completed, then we go ahead and render it using that template. And so at the top level, after we bind the executor for all of these things to run on, you can just say, okay, get me the listenable future of HTML. You don't have to string together all of the RPCs. And the reason that this is so effective, the reason we've had such great success with it, is that you don't have to know the particulars of, okay, here's my top-level user operation. I want to show some HTML. You don't have to know necessarily which RPCs are going to be required to fulfill that request. Maybe someday you add authentication. Now those RPCs just get wired in with dependency injection and part of the graph the same way they always would be. Or, you might even have something that, as you have a bunch of people contributing to the project, individual portions of the subgraph may be replaced, might be modified, and all of this is just like composed as part of the same modular dependency injection framework, but scheduled appropriately so that RPCs start as soon as they can start, and all the results are aggregated as soon as they're completed. Hugely powerful and is part of the solution to how we implement search. This is a pretty easy one. I'm sure that anybody that's used Dagger 2 knows a bit about this. We love the fact that our error messages are available immediately. In your ID, it's a red squiggly line on exactly the right offending element, but the text left something to be desired. We've replaced it with something that looks like this. This is going to be in your latest snapshots. It's a very stack trace looking formulation of the error message. I actually pulled this straight from some build output. This is not synthetic in any way. If you have if you forgot to buy into the coffee pump, you will get exactly this error message, and I think it reads pretty nicely. The coffee pump is injected at the coffee maker constructor. The coffee maker is provided at the coffee maker component maker. I think that should be pretty good for helping improve developer velocity in the future. And finally, project management. I know that all of you in the room, this slide is exactly for each one of you that has to develop against Dagger 2, not from within Google. Development within Google is great, and I argue 100% that it is completely irreplaceable. Every time we make a change to Dagger, it is automatically run against somewhere around 1.7 million test targets, just from all of our transitive users. And there's constant performance testing and monitoring and all of these wonderful things. New APIs are, every time we make a change, every time we introduce a feature, we have immediate feedback at a massive scale. And the fact of the matter is, open source, we might be able to get that feedback, but it'd be much slower and maybe not on the same scale. we have been able to harden APIs and prove viability much, much quicker than we have ever been able to because we develop within Google 3. That didn't work out so well for GitHub. Every once in a while we'd do a sync. It was few and far between, and that was an understandable source of frustration, and frankly, our entire team apologizes for that. But we have now made a substantial effort to do better for you guys. The new release policy that was posted just a little while ago, maybe a month or two, says that there will be a versioned release every 2 weeks. And what that means, and sort of the semantics of that are written down in the policy. But now you can basically expect that you will never be more than 2 weeks behind whatever it is that we're developing. And those releases will be versioned in Maven, no more building snapshots. Hopefully that works for you, and if it doesn't, we really appreciate feedback because we've made an effort just to sort of improve your developer experience. All right, so that's what we've done. Here's what we're doing next. Dagger 2.5 and beyond, and hopefully this is the stuff that will be most exciting for you guys. First and foremost, performance enhancements. We are never going to be done trying to make Dagger 2 run faster. I believe that it's already the most efficient dependency injection framework on Android that exists, and here's how we're going to make it better. First of all, we have a lot of enhancements we want to make to the generated code. I'm going to do you the favor of not showing you huge slides of generated code. But the goal has always been to make generated code look more or less like what you would have written as a human if you had a lot of time on your hands. And the good news is that we took some patterns that sort of look like what we would have done by hand, and we've applied them extraordinarily consistently. The problem is we made generated code that looks like it was written by a human with absolutely no judgment whatsoever. It was like I read my first design pattern book and then just did that over and over and over again. And that's not good. That's not the code that we want to put into production necessarily. So what we've done is we've decided to take a really hard look at the graphs that we are making out of all of our objects and all of our dependencies, and be a little more judicious in which patterns we apply when. And particularly within the next quarter, so by the end of June, we expect to target a 25% reduction in the size of the generated code. Less code means quicker load times, quicker instantiation times, all of those things. We basically expect to see a direct correlation in the reduction of your startup times for applications if you use Dagger 2. And how we do that, first and foremost, is unnecessary providers. One of the patterns we do is we just take a method, we wrap it in a provider. Well, that's kind of like if you were doing a whole bunch of arithmetic with ints and stored references to integers. We force you to box things just to unwrap them again in the next instruction. And that's obviously silly. So we're going through and we are reducing or eliminating all of the cases where we wrap something in a provider just to unwrap it again, because as we know, that's all massively inefficient. We're also getting rid of retained references. And this is your application's memory footprint over time. The implementation right now holds references to every single provider used by the component forever. You might imagine that your application level component, this is a bad thing. Regardless of whether or not we're ever going to use that provider again, we hold a reference. So your in-memory footprint is just bigger than it needs to be. So we are actively working to drop references when we no longer need them. The best example is if you have something marked singleton, you're going to invoke the provider once, you're going to get that instance, then you're going to hold on to the instance forever and never invoke the provider again. We've already made a change that will drop the reference to the provider, so all of that can be garbage collected and you won't feel quite as much memory pressure as you might have otherwise. Now binds. Binds is kind of in the same vein. Binds is another how do we write more efficient code. I'm sure you've all written, seen, interacted with a method that looked basically like this. If you want to provide a binding for pump and you want that binding to be a thermosiphon, you just return the thermosiphon. That feels verbose to me. It has felt verbose to me ever since the very beginning of Dagger 1. And a lot of people have asked for feature requests. How do we do this declaratively? How do we make it shorter? A lot of people just complained about it took too many characters. The word pump appears 4 times in that code example, and that's a little sad. But really, the length of the method wasn't the motivating factor. The really big problem is that if you write an application and you declare this method and it looks exactly like every one of your other provides methods, and then something goes wrong and there's an exception and there's a stack trace, it would be really weird if that method didn't show up in that stack trace. Even if we could say, hey, we know this is doing something stupid and something silly, debugging the application that's all of a sudden missing stack frames would just be wildly confusing. So the question was, how do we express this operation in a way that doesn't actually require any user code? And it's basically just an abstract method. It's an abstract method that we never invoke. But we know abstract methods have no implementation, so it's not necessarily weird that we don't invoke it. Rather than provides, we just say binds. Other than that, the method signature looks exactly the same, but we don't have that weird thing where we just return impl or whatever it is. And what this lets us do, the important thing for your Android application, is that the provider that we used to create, that took the provider for thermosiphon, called get, and then returned it as a pump, that provider no longer exists. We just get to eliminate it. We don't even have to generate code for it ever. And again, that's one of those things, just kind of like static provides methods. Okay, how big a deal is this really? In our survey of, we at Google, we develop everything in one repository. It's nice and it's searchable. This was just under 20% of all of the provides methods in Google 3. Just doing this operation, returning one thing straight out of a method. And if those numbers are anything like your application, that means that about 1/5 of the generated providers will disappear. Great for your method count, great for your deck sizes, great for your APK sizes, etc. This is, I believe, checked in. You should see it at head if you look in GitHub, so you might start playing with it now if you'd like. And we will have great instructions of how you can do some automated refactorings to move from the old style of provides methods to these. I keep forgetting the clicker doesn't work. Memory management tools. Another thing that's obviously pretty important is that when you are on a mobile device, that means you have to be pretty judicious with memory. And particularly we're focusing on the number of allocations in the long-term memory footprint, how much you retain, and how often you create a new object. Because allocations on Android, and this is another one of these things that sort of blows my mind about mobile devices, is they can be surprisingly expensive under the wrong circumstances. It's not the cost of any individual allocation. You just might have bad luck, and you can spend huge amounts of time waiting on one single memory allocation. So we want to minimize the number of allocations we make, so we lower the risk. How do we do that? Well, today we have two options. The first is unscoped. You just don't apply scope, and you get a new instance every time you inject it. That's really great for your long-term memory footprint because you don't retain any instances in the framework. That is really bad for the number of allocations. That means you're just allocating all the time. And so that's understandably not something people are really excited to do. It was fine on the server. It was really the consistent baseline advice on the server. Bad for your mobile device. The other option was scope. Well, scope is exactly the opposite. We create one instance, we retain it forever. You are guaranteed to only get that one instance. Great for the number of allocations because there's only one. Really bad for your long-term memory footprint because we don't know if you're ever going to ask for this thing ever again, so we have to hold on to it for the lifetime of the component. We hold on to it forever. The other thing that I don't think a lot of people consider when they apply scope is that reference has to be stored somewhere. We have to create an object wrapper. That object wrapper holds a reference, and that's stored by the components as well. So it's not only that we're holding the reference, we're holding a wrapper to the reference. It bloats pretty quickly. It's also that, in order to make sure that we have exactly one instance, we have to guard creating that instance with double check locking, which if you've seen the pattern is a volatile field, a null check, acquiring a lock, and another null check. It's definitely significantly more work than just allocating a new instance. And the other sort of consideration that gets thrown in there, and depending on the size and complexity of your app, if you have a component and a lot of subcomponents, in order to share scoped instances among your subcomponents, so for instance, say you have 5 activities and they all want to share one instance, the only place you can put that is in the application level component. All of these things that you want to share suddenly bubble up to the top of your application. When they bubble up to the top of your application, that means that your application scope becomes bigger, becomes more expensive to create, does bad things for your application startup time. So just one more thing that's, not the greatest story for your Android app. So first and foremost, we've introduced reusable. Reusable is sort of a no guarantees type of scope. We say instances can be reused. We don't know whether or not, you need to. It's not a strict requirement. It's not something like a request cache where if you have 3 of them floating around, things will break. But you can reuse them. Like, there's no difference between one and the other. And what this does is it requires, sort of that same object wrapper to hold on to an instance, but we can put that object wrapper anywhere. We can put it anywhere in your application. If you have 5 activities, we can spread it out amongst the 5 activities, keep that startup time low, but within that activity, if you request it 300, 400 times, you'll still only get 1. It's the compromise between unscoped and scoped, and because it has no real semantics, because it's not, tied to a particular lifecycle and sort of floats around your object graph, you can bind this thing at any level. You can put it in your singleton components, you can put it in your, activity components, you can put it wherever you'd like. And, really we have a very elaborate hand wave by which we say Dagger will try to do better than you otherwise would have. This is definitely going to be the type of thing that you can't blindly apply all over the place. The object wrapper still exists. It's still got a little bit of a cost, but definitely worth trying in some targeted places, things that sort of make logical sense, doing some benchmarks, and you might see some pretty decent benefits. The other thing we've just begun working on, this is one of our goals for this quarter, is pressure-sensitive scopes. If you are in an Android application, you're worried about memory pressure, you're probably familiar with on-trim memory, which says, hey, I've got this signal, something has happened, something's changed in the state of my device. Now I'm worried about how much memory. Do what you can to free it. With Dagger, as it stands right now, there's really nothing you can do about that. You can try and garbage collect a whole component, but that may or may not be the right thing for you. So we are working on a mechanism by which you can say, for this particular scope, rather than just holding on to a reference indefinitely, go ahead and make whatever you're holding on to eligible for garbage collection. And we actually use a weak reference to track that, so if it doesn't happen to get garbage collected, if that, despite the fact that there was memory pressure, like nothing actually happened, we'll go ahead and grab it from the weak reference and turn it back into a strong reference when you need it. But generally, the idea is that if you have really large objects that are, only, say, part of your UI, and you get the signal that, okay, the UI is hidden, respond to that particular bit of memory pressure, you can let these objects be garbage collected and then recreate them whenever you need them the next time. Keep an eye out for this. Like I said, we don't have anything to show you. We don't have any samples for you to play with, but lots and lots of design as we try to make this work well for your Android applications and most importantly work correctly. And finally, this is really the hallmark. I've saved absolutely the best for last. For your Android applications, we'll do another quick poll. How many people have found that applying Dagger 2 to your Android applications has been simple and intuitive and didn't require much work at all? Yeah, the chuckles are a bad sign. This is an absolute fundamental change to how we apply Dagger 2 to Android applications and is really the focus of all of our work as it pertains to Dagger 2 and Android. We are driving towards this. As it stands today, this might look more or less familiar. You might have an application component. All that thing does is inject, the application. Pretty straightforward. You have to make a builder. That builder might have an application module that binds the application itself, but this should be pretty familiar. If you want to make an activity subcomponent, it would look something like this. Sort of the same structure. You inject the activity. You have a builder. That takes an activity module. But the funny bit is that you have to put on your component for your application something that lets you generate the subcomponent for the activity. This means that your application, in one way or another, if you're extending a bunch of interfaces or just listing them directly, however it is, the application component has to have a reference to the subcomponent for every single activity. No fun. So what if we didn't have to have that method? Would life get any better? What if we could just do this? What if we could just say, hey, in my application, just go ahead and inject the activity subcomponent builder, and that method doesn't exist? Well, what would that do? You just get rid of that method, which is great, but you'd still have a centralized list of all activities. You'd have, a whole bunch of injected fields, one after the other. So we've just moved the methods to a field, which isn't that great. And an application depends directly on each activity, or at least each activity subcomponent. You have a strong dependency at compile time that says, each one of these fields has to be there. And I think possibly the worst bit of it all is that activities have to depend directly on my application. You can maybe fudge it with some interfaces, at some level in there and do, some tricks. But by and large, you actually have to get a reference to my application and get those fields so that an activity can have its own subcomponent. We still have this sort of circular dependency that we're really trying to break. So let's address this problem. First, if we make a common interface for the activity subcomponent builders, this is kind of the thing that I think everybody wanted to do in the first place, just give me a consistent way to create my activity subcomponents. It might look something like that. We've got some crazy generics, but it's really pass in an activity module and build it. The bit down here, the main activity subcomponent, well, now that builder, rather than listing out those methods in pairs every single time, just extends that activity component builder. Great. Now we can make a map multibinder. That map multibinder just asks for the activity subcomponent builder the exact same way we did before. But rather than doing it directly in the application, we do it in this method. And now, so what we're going to do is the key, like we saw before, rather than being in enum, it's going to be the activity class. We're going to say the main activity. And for the main activity, we're going to associate it with the main activity subcomponent builder. And you can do this any number of times. Pretty straightforward. Now we go back to my application. What would it look like if we did that? You can just inject that map that's class literal of your particular activity type to a builder, and then expose a method, and with this interface, it's just kind of a straw man, that asks for that map, checks to make sure the activity's in there, calls get, returns the builder. What this does, let's walk through the benefits, because there's a lot going on here all at once. Activities are added to the application only by including a module. We have one place. That's something we've been looking for a long time. And that's anywhere in the module. If it's directly on the component or via module includes, we can add that map binding anywhere we'd like. My application right here, doesn't have a reference to any individual activity. Nowhere in that code do you see any individual activity. That means your application and your activities are now finally independent of each other and only connected by the implementation of the component. Again, something we've been looking for a while. Any activity can get to its subcomponent builder through the hasActivity subcomponent builder's interface rather than specifically my application. Now your activities can depend on a common interface without ever having to know anything about the particular application that they live in. And finally, the thing that really differentiates, and again, the thing we really hold sort of most near and dear to our hearts as authors of Dagger 2, is there is absolutely no reflection in order to get this done. We use class literals as keys, but class literals are immediately available and cheap to get a reference to. And it looks kind of like reflection. We get some dynamism in the way that we might want in order to compose our application, but we do it without ever invoking class.newInstance or anything like that. Those maps, because they're the map bindings that we've discussed before, the entire space of your activities is known at compile time. We aggregate them all, and we provide this map to you just so that you can access it in your application. Why do we care? Why have we gone through all of this effort? In addition to being, somewhat more flexible and a little shorter, a little less verbose, what this means now is that if you wanted to test your application, testability being one of those, big tenets of dependency injection, well, I can test my main activity by making a new application that just includes the activity module. We know at compile time whether or not it fulfills all of its transitive dependencies, but we don't have to include all of the other activities in your application in order to fire up a quick little test instance, a test application, particularly tailored to just testing the main activity. All you do is you make a new component. That new component has the main activity module. If it fulfills all the dependencies, it compiles. If it doesn't, it doesn't. You get instant feedback, and you can create tiny little tearaway applications, possibly with mock dependencies, without having to build the entire component structure. We hope that with this change, making new applications, obviously with their new manifest, should be a quick and easy way to get much smaller scale testing or much smaller scoped testing without having to build and wait for your entire application to run and deploy. That is admittedly a lot to throw at you all at once. We hope to present much more sort of within the next couple months. And I'm sure some of you will want to go over this kind of straw man at your leisure. This is really what we're driving towards, is finally making the ability to compose your activities, and then possibly your fragments and views and whatever else is extensions, simple and easy and not quite so redundant, and eliminate that circular reference or that circular build issue that we've had for kind of a long time.